Yeah, today we will talk about car park ventilation.
Car
Okay,
parking
so
ventilation. Okay.
yeah, last week we have just gone through the architectural design. You got some idea.
Architectural.
Yeah,
Okay.
and before we go to the car park ventilation, we will also go through the some design standards. Okay, so based on the design standard, only we
Okay.
are going to do the calculation. Okay, so there are
Okay.
understanding of
Okay.
ASHRAE, pollution mode, fire mode, car park ventilation calculation, then how to do the fan sizing, what is the working principle. Everything we will go through this particular section. Okay.
Okay. Okay.
Okay, so before that, I will just try to show you some example. If you go through our local regulations, okay, like a UAE code, there is a
Okay.
Dubai building green building regulations. You can see there is a parking ventilation. Okay, if you
Okay.
clearly read this particular portion for all buildings with enclosed parking, okay, mechanical
Hmm.
ventilation must be provided to ensure that the carbon monoxide
Carbon monoxide.
concentration, yeah.
Okay.
Yeah, so if you've gone through this particular Dubai green building regulation, you can see for all building with enclosed parking, mechanical ventilation must be provided to ensure that carbon monoxide concentration in the enclosed parking area is maintained below 50 parts per million. Clear?
Okay.
Okay,
Yeah.
so you
Clear.
may ask what is the purpose of maintaining the ppm level, right? For example,
Yes.
okay, let me open one small document. Yeah, you can see here carbon monoxide detection. Okay, carbon monoxide detection
Hmm.
and control system for parking structures. Guidelines for the design engineers. Okay, so if you go
Okay.
through this particular guideline, you can see there are different
Okay.
ppm levels. Okay,
Okay.
yeah. So for example, if you talk about 0 ppm, so it is like a normal fresh air. Okay, if the ppm level goes high, that means the pollution level is increasing. Okay, so what is the
Yeah.
possibility? Maximum allowable short-term exposure. You can see that if you have a 10 to 24 possible health effect with a long-term exposure. Okay, 25
Okay.
ppm maximum exposure for 8-hour workday. Okay, 50 ppm
Okay.
maximum permissible exposure.
Maximum
So
one.
if the ppm level goes high,
This.
it will affect our human beings. Like
Yes.
you may have a headache if you stay there for 1 to 2 hours for 100 ppm, you may have a headache. Okay, and if you see
Okay.
800 ppm, you can see that headache, nausea, dizziness after 45 minutes. So that is why we remove the carbon monoxide, okay, from the car parking.
Yeah.
Right, but we will see that
Okay.
where the carbon monoxide comes from. It comes from the vehicle, right? So you
Yeah.
can see that carbon monoxide, one of the most toxic components of vehicle exhaust. So whenever the vehicle
Yes.
pass through pass through that particular area, if it is enclosed space, then
Okay.
there is a carbon monoxide generation. Okay, say for example, if you talk about battery
Okay.
room, whenever you charge the battery, whenever you discharge the battery, there is a carbon hydrogen emission. Okay, similarly for the vehicle,
Yeah.
you have a carbon monoxide emission. So if the
Monoxide
carbon
emission.
monoxide exceeds certain level, you have a problem, right? So you can see that carbon
Yeah.
monoxide and it affects. So if you read this particular guideline, you will understand that why what is the effect if your cpm if your co level increases. Okay, so that is the guideline here. Okay,
Okay.
so if you go to this particular guideline again, mechanical ventilation must be provided to ensure that the carbon monoxide co concentration in the enclosed parking area is maintained below 50 ppm.
50 per. Mm.
Yeah. So providing a maximum minimum of 6 air change per hour. You heard about normally whenever you do the calculation, they will do the 6 air change per hour. Okay. What do you mean by 6 air change per
Yeah.
hour? It is nothing but your volume of the room. Okay.
Okay.
So volume of the room is what you can say that, say for example, if I type here, first of all, when you calculate the Q is nothing but volume of the room
Into
or of the
AC,
space
ACH.
of the space
Okay.
multiplied by ACH.
ACH. Yeah.
Okay, so this is the formula basically, right?
Yeah.
Okay,
Yeah.
now what
Right.
is the volume of the space? Say for example, I will tell you that I have a room area and I have a height of the room. So that is that from there I can able to get volume of
Okay.
the room,
Volume
right?
of the flow. Yeah.
Okay,
Right.
so that one you can say for example, when I do the calculation, I will calculate my room volume. I will get meter cube because my area is in meter square and the height is in meter. So
Meter.
when I calculate, it is in meter cube.
Cube.
Okay. So when I calculate my
Okay.
air change per hour, it is actually speaking, it is the air change per hour. Okay. So that means it is like per hour. Okay.
Okay.
So when you multiply both, what you will get, basically you will get meter cube per
Meter
hour,
cube
right?
per hour.
So this
Yeah.
is what you will get. Okay. So it is very simple that
Yeah.
you will calculate volume of the space, which is meter cube, and multiply by 6 air change per hour. You will get total meter cube per hour. So this is your fan capacity for the normal, for the pollution mode.
Yeah.
Okay. So whenever you have a car park ventilation, there are two modes. One is the pollution mode. Another one is the fire mode.
Okay.
Okay. Pollution mode is to maintain the space. Like say for example, if you want to remove the pollution from that space, okay, what is the pollution? It is nothing but CO concentration. Okay, to maintain the fresh air inside the space, you must remove the CO concentration. Okay, so that is called pollution mode.
Okay.
Okay, so to maintain that, you are going to calculate the fan capacity. Q is equal meter cube per hour is nothing but volume of the space multiplied by air change per hour. So you will get the airflow rate for the pollution mode. Clear?
Okay. Yeah. Clear.
Okay. Now we will go in little bit detail. Okay. What is that 6 air change per hour? Everyone say that 6 air change per hour. But what is the criteria? Okay. If somebody says 6 air change per hour, you will just do 6 air change per hour and you will do that calculation. But we also to understand why that 6 air change per hour is arrived, right? So we will go little bit deeper. Yeah. Okay. Before that, I will also go through the UAE fire code as well. Okay, that is for the smoke fire ventilation. Okay, so that we will do the pollution mode and then we will come to the fire mode. Okay, so first of all, I will go to ASHRAE guideline, which is ASHRAE 111. This is like 1999. Will give you the clear explanation. Okay, about the parking garages. So if I read this particular guideline, automobile parking garages are either fully enclosed or partially open. Okay. Fully enclosed parking areas are usually underground and require mechanical ventilation. Okay. Partially open parking levels are generally above grade structural decks having open sides. So sometimes the people, they may not install any ventilation system, forced ventilation, or they may go for jet fans just to make that space clear. Okay, it is not actually forced ventilation. Jet fan will clear the smoke from that particular space. Okay, so that we will discuss. Okay, so you can see that the operation of automobile present two concerns. So the most serious is the emission of carbon monoxide. Clear?
Yeah, clear.
With its known risk. So you know that if you read that guideline, the CO parking garage guideline, you know that if the CO level goes high, what are the impact for the human being? You know that, right? For example, I will share you this guideline. You can go through and you will get that idea. The second concern is the presence of oil and gasoline fumes, because whenever you see the fuel, it carries the oil and gasoline, okay, which may cause nausea and also headache as well as present as a fire hazard. Okay, so sometimes the people may, when you see that some people, they may have some allergy, okay, or they may it's not suitable for the human being sometimes when you smell the diesel or gasoline, right? Okay, so whenever the CO monoxide, carbon monoxide, or whenever you have the smells from the oil or gasoline, so that everything to be taken out, so that it will have it can maintain indoor air quality inside the car park level. Okay, if somebody walks inside the car park level, they feel fresh. Okay, they don't feel like a lot of carbon monoxide. Okay, there is a lot of gasoline smells, which will have a human health issues. Okay, to avoid that, we are going to have a proper ventilation system. Okay, so that ventilation system, how to calculate the Q flow rate? We have a total volume of the space multiplied by air change per hour. Okay, so that is what we are going to calculate. Okay, and also you can see some standard ASHRAE standard. Additionally, concern regarding oxides of nitrogen and smoke haze from diesel engines may also require consideration. Okay, however, the ventilation required to dilute carbon monoxide to acceptable level also control the other contaminants satisfactory, provided as per the percentage of diesel vehicle does not exceed 20%. Okay.
Okay.
If you read this one, for many years, the model codes and ASHRAE standard 62 and its predecessors standard have recommended a flat exhaust rate of 0.0075 meter cube per second for every square meter of area.
Okay.
Okay, or 6 search engines per
For
hour. So
six
here you
days.
can see that there is a basis. Sometimes you may see whenever you are working with a consultant, okay, they may do the calculation based on 0.0075
Yes.
meter cube per
And
square
submit.
meter. So this is based on what? They
Okay.
based on ASHRAE standard. Okay,
I understand.
for the enclosed car parking. But because vehicle emission have been reduced over the year, because this is very long time back, this is 1999, you can see that
Okay.
0.0075. But recently there are a lot of reductions, okay, because the vehicle, it's all,
Yeah.
we are getting very good quality vehicle, and there are very too much regulations for the carbon for the engines for also, so that there are recently there are many quality engines are being production is made has been the vehicle industries has been producing lot of quality engines, so your emission level is going day by day in coming days. Okay, so if you talk about 2025, maybe this value is not applicable, maybe this is lesser than. Okay, but as a standard practice
Okay.
we consider 0.0075 air changes. So you can see that, but because vehicle emission have been reduced over the years, ASHRAE sponsored to study to determine ventilation rates to required control contaminant level is enclosed parking facilities. Okay. The result of the study, which are
Okay.
summarized here, found in some cases much less ventilation than 0.0075 is satisfactory.
Okay.
Okay. So how to calculate this value?
So
That
what
is
is it?
again we are going in detail. Okay.
Okay.
However, local code may still require 0.0075 meter cube per second per meter square or 6 searches per hour. So just now we have seen the Dubai building code. They are clearly saying that 6 searches per hour. Okay, even though there is a
Yeah.
lesser emissions. Okay, so the engineer may require to
Okay.
request ventilation or waiver from the authorities having age AHJ to implement the recommended given here. Okay, so if you talk about the detailed ventilation calculation, okay, the design ventilation rate required for an enclosed parking facility depend on four factors. One is the contaminant level acceptable in the parking facility, number of cars in operation during peak condition. Okay, so how that number of car parks been arrived?
Okay.
Say for example, remember we have seen that Dubai building code or Turkey, we have seen that how that car parking space is being calculated, right?
Yeah.
If you talk about basement, you may see number of parkings. Okay, so each and every parking bay is being calculated based on some standard dimensions.
Yes.
Okay, and between two car parking, what is a dimension? And if you have a parking opposite to each other, what is a dimension? And what is the
Yeah.
roadway, the pathway, what is the dimension? Everything we have seen, right? We have idea how the
Yes.
number of car parking is being arrived, and it depends upon the different applications. Say, for example, occupation category. If you go to residential, you have a different type of number of parking to be allocated. If you go to commercial building, the number of car parking is being allocated. Okay, if you go to mosque area, religious area, if you go to hospitals, so the number of car parking is being calculated based on the applications that we have seen in our architectural guidelines. Okay, now we know what is the number of car parking and we know the number of cars, right? If you know the number of car parking, you know how many car parking will be parked. Okay, and length of travel and
Okay.
operation time of cars in the parking garage. Sometimes you may see that there are a lot of vehicles parked in the car, and there are some few car traveling through the parking areas. Right? For example, if you
Yeah.
if I draw some car parking, if I draw some basement, okay, you will find a lot of parking bay. For example, okay, just I'm giving you some example.
Yeah.
It is, doesn't mean that all the parking we have to calculate, okay, because most of the car, maybe three cars are parked, but maybe only one vehicle will be
Is going to
moving
go.
through the parking. Okay, so whenever it goes through
Yeah.
the parking, what will happen? It will emit gas, right? Carbon monoxide.
Yes.
Okay, so that is what we are going to see here. Length of travel and operation time of cars in the parking garage, emission rate of typical car under various conditions. So you can see the contaminant level. Okay, contaminant level criteria. So ACGIH recommends threshold limit of carbon monoxide of 29 milligram per meter cube is allowed for an 8-hour exposure. Okay, if you have an 8-hour exposure, you can have a maximum of 29 milligram per meter cube. This is allowed. Okay, but more than that, there is a health issue. And the EPA, there is another standard, has determined that or near sea level exposure of CO concentration of 40 milligram per meter cube for up to 1 hour is acceptable. Okay, so this, if you have a 25 ppm, up to 8 hour is acceptable. But if you have a 40 milligram per
Okay.
hour for different standard, they are saying that 1
45
hour is
ppm.
acceptable.
1 hour
Okay,
is
for
okay.
installation above 1000 meter, more stringent limits would be required. Okay, European countries maintain an average of 40 milligram per meter cube, 35 ppm, and a maximum level of 230 milligram per meter cube. Okay, that is called 200 ppm. Okay, you're getting some
Okay.
idea.
Yeah.
Okay, opinion of the various agencies and countries differ or acceptable CO limits. Okay, each and every country have different ranges. Okay, and you can also see that average entrance and exit time for vehicles. So if that one vehicle comes into the space, it take 35 seconds to reach to the car parking bay. Average. Okay, it doesn't mean that we are calculating exactly, but this is as per code, as per average. What is that average exit time when somebody trying to take the vehicle out, and when the time of exit will take around 45 seconds. Okay, you have a level 1 criteria, level 3 criteria, level 5 criteria, depends upon the application of the project. Okay, maybe a residential plot,
Okay.
maybe it will take very less time, and if you go to office buildings, maybe it takes some time, and if you go to shopping malls, may take more time. Okay, so this is average entrance and time vehicle for exit. Okay, so here you can see the
Okay.
predicted CO emission level in parking garage, how much CO it emit. Okay, during the summer and during the winter. Okay, because during the
Okay.
summer you have a maybe, the because the winter will have a lot of car movements, for example. Okay, or due to the temperature, maybe it emit more gases compared to the summer. Okay, so you can see that this is
Okay.
the the predicted CO emission in parking garages. If you talk about 1991, 1996, they are just comparing hot emission and cold emission. Okay, so they are just calculating this much of gram per minute is emission is happening in the car park. Okay, so
Okay.
this is a standard. This is standard. Okay, we don't need to go that much deeper, but we are just trying to understand how that 6 change per is being arrived, so that when you are when you discuss with the consultant, or when you discuss with any manufacturers, you will have some basic idea. Okay, and the number of car parks in
Okay.
operation. So it doesn't mean that, as I said, all the cars are in operation. Okay, normally you say that number of cars operating at any one time depends on the type of facility served by the parking garage, depends upon the facility. For a distributed continuous use such as apartment house or shopping area, the ventilation is generally from 3 to 5% of the total vehicle capacity. Clear?
Yes.
So only three. If you have 100 parking, just take only three parking of the vehicle. Okay, because even if
Okay.
you go and see somewhere, you will, if you go any of the basement or any of the enclosed parking, you will see rarely the cars are going around here. Okay, so that is expected 3 to 5% out of 100 out of 100 cars. You may see like 5%. Maybe if you it could reach up to 15 to 20% for peak usage. Say for example, uh, in my during my office hours, commercial buildings, you will see lot of cars entering during the office hours, but after some time it will not be there. Okay, so that
Yeah.
percentage is around 15 to 20%. So this we
Twenty
can apply,
percentage.
depends upon our building. Okay, it doesn't, maybe there is a sample calculation, but it doesn't mean that
Mm.
you have to follow this calculation. Okay, you also can assume, or you also can uh, think about what is the type of building we are working, and based on that we can apply
Yeah.
the percentages. Okay, this is our decision. Okay, Ashray says that
Our
this is
decision.
the range, but we can decide. Okay, and
Okay.
length of time of operation. So how much length of time of operation? The length of time that car remains in operation in a parking garage is a function of the size. It depends upon the size. It doesn't mean that you have to just take 2% or 3% or something like that, or some seconds you have to take like that. Okay, it depends upon the your consideration. Depends upon the actual project. Okay, the length of the time that a car remains in operation in a parking garage is a function of the size and layout of the garage and the number of cars attempting to enter or exit at a given time. This time could vary from 60 seconds to 600 seconds. You can judge, depends upon your application. But on the average, it
Okay.
usually ranges from 60 to 180 seconds. Okay, the table list approximate data for vehicle movement. Okay, this data should be adjusted to suit the specific physical configuration of the facility. Clear, right?
Yeah.
Yeah, this is the car emission rate. The operation of the car engine in the parking garage differs considerably from normal vehicle operation, including normal operation in a tunnel road. Okay, so if you talk about this particular area, it's about car emission rate. Okay, so how to calculate, determine the flow rate. Remember that we have calculated Q equal to air change per hour multiplied by volume of the flow rate. But here we are going to
Yeah.
do based on the emissions, how much emission. So you can see that to determine the design flow rate required for ventilation to enclosed car parking garage, the following procedure can be followed. So you can see that formula here. Okay, how you calculate number of cars in an operation during a peak hour, which is N, and average CO emission rate for typical car, grams per
E.
hour, and average length of operation and travel time for typical car. Okay, CO concentration acceptable in garage, ppm, how much it is acceptable. The total floor area of the parking. Okay, determine peak generation rate, how much peak generation it is going to create. That is the equation you are going to calculate per parking garage per unit floor area using these equations. This is the equation. G equal, G is nothing but
ND.
parking.
Yes.
Determine peak generation rate in grams per hour. How much smoke it is going to generate. It depends upon number of vehicle. It depends upon the CO emission rate for typical car, and it depends upon how much length it traveling, and depends upon the area. Okay, so if you apply in this factor, in this equation, you will get what is the total peak generation rate. Okay, then normalized value of generation rate using reference. How much percentage when you are comparing, how much of percentage you are generating compared to the standard maximum. Okay, see for example, if you talk about
Okay.
using reference value G0 maximum, you have a 26.7 gram per meter square. Okay, so this is the standard normalizing value of generation rate using reference value G0. How much it can go maximum? 26.7 gram per hour per area meter square. This much is the standard. Okay, 26.7 gram per hour for every square meter. Okay, so this is a standard. This reference value is based on the actual enclosed parking facility. Okay, there is some standard CAR-T 1998 standard. Okay, based on that. Okay, so how you calculate the frequency? The percentage 100 multiplied by G divided by GO. What is G? You are calculating here, and what is GO? Which is the maximum.
Okay.
So you will get the percentage.
26.
Then you are going to determine the minimum required ventilation rate per unit area using the correlation presented by equation depend on the maximum level of CO concentration. So what is the equation here? This is the equation. Q equal to CFO. Okay. So what is the C you are going to maintain?
Okay.
Depends upon the factor. If you want to maintain 15 ppm, this is your factor. If you want to maintain 25 ppm, this is your factor. And if you want to maintain 35
Okay.
ppm, this is your factor. This is as per ASHRAE. Okay.
Okay.
Okay. Now you are going to calculate considering two vehicle. You are going to do some example. Okay. Considering two level enclosed
Okay.
parking garage with a total capacity of 450 cars, a total area of 9,000 square meter and an average height of 2.7 meter. The total length of the time for a typical car park is around 120 seconds. 2 minutes is nothing but 120 seconds. Determine the required ventilation for the enclosed parking structure and in a ACH so that the CO level never exceed 25 ppm. So you are going to calculate based on 25 ppm, right? Assume that the
Okay.
number
Right.
of cars in operation during peak hours is 40% of the total vehicle capacity. So here maybe it is like shopping
Okay.
complex or some different application. So you are considering 40% of the vehicle capacity, right?
Okay.
Okay, now you know the garage date. You are going to calculate G. You are going to calculate frequency. You are going to calculate Q, and you are going to calculate the ACH,
Okay.
right?
Yeah. Right.
Okay, I will not go in here because you will go and practice it. Now, whatever I explained here, you will try to use this equation and can you do one calculation for one project?
Okay.
Maybe you can take one basement for your project and try to
Yeah.
calculate what is the flow rate required and what is the air change per hour. If you cannot able to solve it, I will explain you next week.
Okay.
Okay,
Will try.
because if I explain, maybe you will not go in detail. So I want you to go in detail. I will be sharing all the guideline here and practice and come back to the next week. Then we will go to the fire mode. Clear?
Yeah. Clear.
Okay. So I will be sharing. I think I have shared this material, right? Car park ventilation. You downloaded.
The car park ventilation I didn't get.
Okay. I will be sharing you this material. Download that material and whenever you have any queries, ask in the group and the people will answer it.
Okay.